welcome everyone to our clarification video on tides. Hopefully you've already watched the YouTube video that I shared with you on tides. This video is going to be to help you actually get your notes filled out in case you didn't catch all of the information the first time, and then also hopefully to clarify a few key concepts. So tides are the rising and falling of sea levels caused by the gravity of the moon, the sun, and the rotation of the Earth. So the gravity of the moon and the sun create the tides, and then the Earth rotates in and out of those water bubbles. So it rotates into a high region of water, the high tide, and then out of that into a low region of water, the low tide. So it's the Earth rotating that also plays a role on why high tides alternate with low tides. And since the moon is closer to the Earth than the sun, it has a larger impact on tides. Even though the sun is millions of times larger in mass, the moon has a bigger impact on our tides because it is so much closer. The moon pulls on the ocean nearest to the moon the most, which causes sea levels to rise. You can think of the moon as the gravity is actually pulling the ocean towards the moon, and it creates a tidal bulge. But the Earth also moves slightly as well. So the Earth then moves back into that tidal bulge, and the water on the opposite side from the moon stays put. So we get tides on both sides. And I'm going to create a drawing that will help you hopefully understand that. And if that doesn't work, right after this, you're going to see a rubber band demonstration of this process as well. But first, the drawing. So in this drawing, here's our moon, M for moon, and here's our Earth. And you can think of the fact that the Earth is largely covered in water. So, right, if I did like a dotted blue line going all the way around the Earth, that represents, maybe 60 to 70% of the Earth's surface is covered in water. And the gravity from the moon, right, the gravity from this moon is going to pull on the Earth's oceans. It's going to pull on every part of the Earth, but it doesn't pull equally. So the closer you are to an object, the more its gravity impacts you, which means the moon's gravity is strongest at the point on the Earth that's nearest, so it would be the strongest, and the moon's gravity is weakest at the point of the Earth that's furthest away. So keep just trying to remember that. The moon's gravity is strongest at the point closest to the moon and weakest at the point furthest from the moon. So the point where the moon is the strongest is going to pull the ocean towards it. And this is a large exaggeration. You wouldn't actually be able to see the tide. A really large tide might, change by 3 or 4 feet. And on the scale of the entire Earth, that's not noticeable from space. So this is a huge exaggeration. But the moon's gravity is the strongest at the point nearest to it. So it pulls the ocean towards the moon. But the moon also pulls on the center of the Earth. So if we're going to show lines that are actually demonstrating how far things are moving, maybe I'll be a little bit more precise with my lines here. So the ocean in blue will move the most. It's going to pull the most towards the moon. The center of the Earth, which are there in black, also moves towards the moon, but not as far. So the ocean moves further than the center of the Earth, so there is still a high tide. And then the part that moves the least, a much smaller line, is the ocean on the far side of the Earth. So because the center of the Earth is moving further than the opposite side, the water on the opposite side, it creates another high tide. So you end up with a high tide on the opposite side of the Earth, or from the moon, so opposite of the Earth from the moon. You end up with a high tide on the side of the Earth that's closest to the moon, and then your 2 low tides are on the other sides of the Earth. So 2 high tides, 2 low tides, and then as the Earth rotates, it'll move you as an observer on the surface of the Earth would move in and out of those high and low tides. And if that drawing doesn't help, right now I'm going to cut and we're going to look at a rubber band experiment showing this in more detail of how the moon pulls in one direction but creates two high tides. So we'll look at that now.
The purpose of this video is to show how even though the moon is only pulling on one side of the Earth, it can create a high tide on both opposite sides of the Earth. So for this demonstration, I'm using a rubber band. This blue mark here at the 2 inches line on the ruler represents the edge of the Earth where there would be ocean on one side. This mark here at 3 inches represents the center of the Earth. And this blue mark at 4 inches represents the ocean on the other side. So we have, imagine this is just a circle extending all the way around, right? And we have our Earth and we have our 2 edges. And then what we're really looking at here is if I pull on one end of the rubber band, that kind of represents the moon's gravity pulling. So I'm going to pull this mark here at 4 1 inch further. And it's now sitting at 5 inches. Well, as you can see, every part of the rubber band has moved closer to the moon, right? So every part of the Earth would move closer to the moon. We have the 2 inch line now sitting at around 2.5 inches. The line that was at 3 inches is now almost to 4, and the line that was 4 inches has moved a full inch to 5. But more importantly, there is now more than 1 inch from the center of the Earth to each ocean. So before, when this is not stretched out, it's exactly 1 inch from each edge of the Earth to the center of the Earth. And now it is more like 1.25 inches. And that's on both sides. So even though I've only pulled the Earth towards the moon in one direction, each side of the ocean is now further away from the center of the Earth. This represents a high tide on the near side to the moon and a high tide on the far side from the moon. So hopefully this helps clarify how even though gravity is only pulling in one direction, that I can get a high tide on the side of the Earth nearest to the moon and a high tide on the side of the Earth furthest from the moon. Thanks for watching.
All right, welcome back. Let's finish writing in our notes here. Hopefully that rubber band demonstration was helpful. So since the moon, so we just covered the moon pulling opposite the rubber band helped. So since the Earth rotates every 24 hours, we pass through the tidal bulges twice a day. So we go through 2 high tides and 2 low tides every day. And when the moon, the sun, and the Earth are aligned, the tides are the biggest, and we call these spring tides. They actually happen every single month, twice a month. They're not only in the spring, it's just the name spring tides. When the moon, the sun, and the Earth form a right angle, the tides are the lowest. You could think of this as the smallest, either one's fine. And we call these neap tides. So let's take a look at that here in this picture. In this first scenario, the sun, the Earth, and the moon all form a straight line, which means the gravity of the sun and the moon are working together. That creates the biggest high tides, which means it is a spring tide. In the second image here, the sun, the Earth, and the moon form that right angle, which means the gravity of the moon and the gravity of the sun are slightly canceling each other out. The high tide will not be as large. So this is a neap tide. Two more. The third scenario, the moon is now in between the Earth and the sun, but they still form a straight line, so their gravitational forces are all acting together, creating the largest tides. So this is also a spring tide. And then the last example, you can see that right angle again, creating another neap tide. So hopefully this video, as well as the rubber band demonstration, has helped make sense of why we have high tides and low tides. As always, thanks for watching.